All right, hello everyone. Welcome back. I'm Sasha, and welcome to the next lecture for Geography 101. Today, we're going to be talking all about climate change. I know I've mentioned climate change in previous lectures, but I think it's important that we kind of dispel some rumors you might have heard about climate change because there's a lot of misinformation about the topic, and it's probably one of the most important topics of our era. And so knowing the science behind what's going on with climate change is really important. You can see in the background here that global temperatures have been increasing a lot, and we'll talk about that in a bit. Um, so one of the first things you may have heard about climate is that maybe it's not actually cooling. I've heard that some early scientific papers have actually predicted that there wasn't any warming, and there's actually global cooling. But that's just not true. So already our climate has warmed by 1.8 degrees Fahrenheit. That's around 1 degree Celsius since 1990. And we can see that in all of the different climate records that we have from NASA and NOAA and from other agencies around the world. That since the 1970s, especially, the climate has been rapidly warming. We don't only need the satellite record in order to know that the Earth is warming. We have over 10,000 weather stations throughout the world that are measuring temperature and the climate. And we can see what the temperature of the Earth is based off of these combined weather station data. And we can combine that with the satellite record. So here you can see the blue is the weather station data, and green and red are two different satellite records, and they match up incredibly well, and they both show the climate has been steadily rising in temperature. Not only is the air temperature rising, but also ocean temperature is rising. This is data from NOAA that shows that ocean temperatures have already increased by nearly 2 degrees Fahrenheit, and that rate is increasing with the oceans getting warmer and warmer. You can see here that because the ocean is so good at absorbing energy, it's actually absorbing about 93% of the increased energy due to global warming. And only about 2% of that increased energy due to stronger greenhouse effects go into the atmosphere. And about 1% go into melting glaciers and ice caps. So if it wasn't for the ocean, our planet and the atmosphere would be significantly warmer than it is now. So the warming that we see now is quite dramatic. You can see here this is a climate record from an ice core, and the temperature right now has been skyrocketing far beyond the temperatures that we've seen in the recent past. And from even further back records, we can see that this is the warmest climate we've ever had in the past 125,000 years. So this is truly unprecedented warming. All right, but you may have heard that scientists don't even agree about climate change. There's no consensus, and there still need to gather more data. This is not true either. So 97% of scientists agree that climate change is happening. There's been several different studies that have looked at different scientific papers, have surveyed climate scientists. These are people actually working with climate models, collecting climate data, and overwhelmingly there's a consensus that global warming is happening and it is human caused. On the other hand, the media does not represent that at all. And there's significant amount of bias towards misinformation about climate change that has led many people to not realize that there is a scientific consensus. And you can see here that nearly third of the media outlets cast some amount of doubt about climate change. And as a result, less than half of the American public actually believes that there is a scientific consensus that there is. We can see here that these are news programs, and whenever they talk about climate, which is fairly rare, the majority of the time it's not a scientist that's actually talking about it. Only 16% of the time, whenever they're talking about climate change, is it a scientist. And the majority of the time, it's some media figure or a politician. And this is seen across all different platforms that 19% of news coverage in CNN cast doubt about climate change, and nearly 3/4 of the news coverage on Fox presents misleading or inaccurate information about climate change. So the media just isn't doing a very good job at showing that climate scientists agree that climate change is a major issue. Also, whenever there is dialogue about climate change on the news, it often ignores climate change when it would be relevant. You can see here in this top chart that news agencies frequently covered Hurricane Dorian, and Hurricane Dorian was significantly made worse due to climate change and increased sea level rise. And yet only one report even mentioned climate change and how it's related to Dorian. Additionally, whenever news agencies are talking about wildlife and how they've been impacted, extremely small percentage of them, 1.6% for television and 6% for print, even mention that climate change might be affecting these wildlife populations. So it's just completely being left out of the conversation, even though it's extremely relevant to many different sectors. And we can see what the IPCC says about it. The IPCC is the Intergovernmental Panel on Climate Change. It's kind of the largest body presenting research on this. And they say that anthropogenic greenhouse gas emissions have been detected throughout the climate system and are extremely likely to have been the dominant cause of the observed warming since the mid-20th century. And whenever the IPCC says extremely likely, that's actually related to an actual value that they gather from statistical models. And that means that they have an over 95% confidence that statement is true. So they put a lot of weight to the fact that the entire scientific community thinks that this is a major issue and it's human caused. All right, but you may be saying carbon dioxide is not even related to warming, and carbon dioxide is just good for plants and we shouldn't be worried about it. And you might love carbon dioxide. It's pretty ridiculous, sure. But it's available on Amazon. So yeah, this is not true either. So we've known about the connection between carbon dioxide and Earth's temperature since 1896, when Svante Arrhenius first published about it. And since then, we've had hundreds of different scientific papers that have concluded that there is a direct causal link between CO2 in the atmosphere and global temperatures. And this is because CO2 acts as a greenhouse gas. We talked about that in previous lectures with the greenhouse effect. And so CO2 absorbs infrared light. You can see the absorption spectra of CO2 here. And so CO2 is particularly good at absorbing wavelengths of light around 3 microns, 5 microns, and in the teens of microns in length. And because the Earth is emitting a lot of radiation around those wavelengths, it's really important for trapping in heat that would otherwise get lost to space. And because of this increase in CO2, we can have what's called positive feedback loops. This is when one process leads to another that then causes that first process to increase as well, and you have a vicious cycle of more and more impacts as climate change gets worse and worse. So even though CO2 concentrations in the atmosphere are only around 0.04%, it can lead to some really significant impacts, especially since the more CO2 that's in the atmosphere, the more water vapor from the oceans gets evaporated, which also can act as a greenhouse gas. And you can see some of those positive feedback loops here. When you have increased CO2, you have increased greenhouse gas effect, and then therefore increased temperatures. And as a result, oceans get warmer and the solubility of CO2 decreases as the gas comes out of the ocean water, and that just releases more CO2, which warms up the climate even more, and this cycle continues on and on. And the same thing can be said about permafrost. As temperatures warm, you have more melting of permafrost, and the carbon that's stored in that permafrost gets released, and therefore there's more CO2 in the atmosphere, and you have this vicious cycle again, this positive feedback loop. And so small changes in the amount of CO2 that we emit can have a big effect on the amount of climate change that we observe. So temperature has also been related to CO2 through ice cores, and ice cores are very good at showing proxies for temperature as well as CO2 concentrations because they have small bubbles in them that store atmosphere from thousands of years ago. This is the Vostok ice core research station, where they're doing an incredibly deep ice core drilling project, or did at least, all the way to the bottom of Antarctica. And you can see the results of that study here, where the CO2 concentration in blue is extremely well correlated with the temperature record in red. And these really go hand in hand with each other. All right, but Earth's climate has always changed. Why is this warming any of interest? Back billions of years ago, yes, the climate was warmer than it is today. We had a few events before that were warmer. We had the last glacial maximum, which was the LGM, which we had a low point in our temperature. But yes, the Earth's climate does fluctuate. But the rate of change that we're currently experiencing is very much unprecedented. And we can tell that through what we call proxies. So we can look back on the Earth's climate and see what the temperature was through a variety of different mechanisms. And we use the isotopes in different substances in order to relate that back to temperature. And one of those is using ice cores, like I just talked about. So ice cores contain oxygen-18, which is a particularly heavy isotope that's found in ice, H2O. And so that oxygen has an extra 2 neutrons. And the reason why oxygen-18 concentrations are particularly good at relating to temperature is because oxygen-18 is heavier than oxygen-16. And so it's harder to evaporate oxygen-18 from the ocean than it is oxygen-16. And so when there's not a lot of energy available, when temperatures are low, the majority of the oxygen that's evaporated is oxygen-16, and that will eventually snow out and form that ice that becomes the ice core. But when there's more energy available, when temperatures are higher, more of that oxygen-18 gets evaporated and therefore can be snowed out onto the landscape. And so there's a direct correlation between the temperature at which the evaporation occurs and the concentration of oxygen-18 in that ice. And so we can use that as a proxy for paleoclimates. Additionally, we can use tree rings. This is called dendrochronology, the study of timing of different tree layers. And you can see here different tree layers here. And we can use multiple different trees and match them up with each other in order to go very far back into Earth's climate, hundreds or thousands of years. And we can tell from the thickness of these tree rings, as well as their chemistry, what the climate is. Generally, you have thicker tree rings when you have more moisture and more precipitation available for that tree. And then also we can use sediment cores. So we send a big core down to a lake bed or the ocean floor, and we pull up a column of sediment like these, and we can tell based off of the layering of that sediment and the chemistry in that layer what the temperature and chemistry of the past climate was. And one of the ways that we do that is with dinoflagellate cysts or foraminifers. And so these are tiny little shelled organisms that can deposit on the seafloor. And because they contain carbon in their shell structures, we can use that carbon and date it and do carbon-14 dating in order to relate that back to a specific date, as well as do some oxygen-18 in order to figure out what the temperature is in that particular layer of the sediment. So CO2 concentrations are extremely unprecedented right now. So concentrations have risen 100 parts per million in the past 60 years. The last time that the concentration of CO2 rose by that 100 parts per million, that change took over 10,000 years. So a change that once took 10,000 years has now taken only 60 years. And that is something that's truly unprecedented in Earth's climate and has caused the Earth's temperature to increase at rates never seen before in modern records. And just as a reminder, the Earth's climate, when the CO2 was at concentrations it was at last, at this concentration, it's not an environment that we want to be living in. CO2 levels have fluctuated throughout history, but the last time that CO2 concentrations were this high, sea level was 20 meters higher than it is today. So if we want to live in that sort of society where we have these elevated carbon dioxide concentrations, we have to expect also that we're going to be living in an environment that's not as conducive to human activity. This would be the shoreline of New Jersey under that scenario. Additionally, the climate of the past was mainly driven by cycles called Milankovitch cycles. These are changes in the Earth's orbit that affect how much solar radiation the Earth is exposed to. And these can cause slight variations in Earth's exposure to solar radiation on scales of tens to hundreds of thousands of years. But these variations are fairly small, and the warming and the change in energy because of climate change that we've observed far outpace the amount of warming that would be resulting from Milankovitch cycles. And so there's 3 different processes going on in Milankovitch cycles that kind of drove a lot of the climate change that we saw tens or millions of years ago. One of those being eccentricity. So eccentricity is how oblong our orbit is, how elliptical it is. So from more circular to very elliptical, and that change in our orbit occurs roughly every 100,000 years. And then there's precession, which is the process in which the axis of rotation of the Earth kind of wobbles like a top, and that axis kind of moves around in a circle that can change about every 24,000 years. And it's kind of wobbling like a top as it rotates around and moves around the sun and points in different directions. And then lastly, there's tilt. And so on a scale of roughly every 41,000 years, the Earth's axis tilts from about 21 degrees to a little over 24 degrees. And that tilt of the Earth can also affect how much sunlight the Earth absorbs. And we can see that effect on the amount of energy here. So these are the different effects of precession. Remember, that's the how elliptical our orbit is. The obliquity, which is the wobble, and the eccentricity. And so these are the solar forcings that result of those different processes. And the stages of the last major glaciations are very well correlated with how the solar forcing has changed because of Milankovitch cycles. But if we were to plot where we are right now, it would be somewhere way up here on this bottom graph. And so we've completely surpassed the amount of forcing due to Milankovitch cycles by the forcing caused by human activity. So the next thing you might have heard is that global warming is actually caused by solar activity or volcanoes. Maybe you've seen headlines such as this, that hotspots are more closely causing global warming than human activity. But this also is not true. So here in yellow is the graph of the intensity of the sun due to changes in hotspot activity. And so the more hotspots that occur on the sun, the more energy it outputs and the more energy that the Earth receives. However, the solar activity and hotspot activity of the sun has been steadily decreasing since the 1950s, whereas temperatures have been steadily increasing. So there's just not a match between solar forcing and global temperatures. And if it was just solar activity, we'd expect temperatures to fall instead of rise like they are now. Additionally, volcanoes aren't the culprit either. Volcanoes tend to actually cool the Earth's climate. Volcanoes release a lot of aerosols, and those aerosols have a very high albedo, high reflectivity. And so their result is that they can cool the climate significantly. You can see here is the forcing caused by different volcanic activity, and the last major volcano eruption, Mount Pinatubo, caused cooling for about 3 years. And after that point, most of that ash and aerosol falls out of the atmosphere, and there's very little effect on climate. So while volcanoes can have dramatic short-term impacts, they're definitely not increasing, and they're definitely not causing the warming that we're seeing currently. We can see here, this is the solar forcing and change in temperature due to solar activity in red. And this is the change in amount of energy in the Earth due to volcanoes in brown. And it in no way matches with the observed temperatures that we see, and it much more closely follows human forcing. Yeah, but you may be saying global warming isn't actually caused by human activity. And this you would not be alone in saying. Human activity is not something that most of the United States actually believes is the major cause of global warming. There's only a few states where the majority of people think that humans are the main cause of global warming. That's slowly changing, and more people are realizing that global warming is human caused, but it's definitely not the majority opinion right now. Whereas it should be. It's the truth. We can see here we're plotting different effects that cause changes in Earth's climate, including ozone, land use changes, and aerosols, and as well as greenhouse gases. And these are the human-caused factors that influence climate. And all of those together very closely line up with the observed warming that we see. And so it's extremely likely that the warming that we see is related to the human factors that are changing Earth's climate. And we can see here as well, we can plot the natural factors, including that solar forcing, including that volcanic activity, and the natural factors in no way match up with the observed warming, whereas the human factors do. We can use climate models in order to plot what is the effect of each individual factor on our Earth's climate. And we can see here, for example, in this kind of swamp green is the effect of volcanoes. Aerosols are in red. Land use change, generally when you have deforestation, you have more reflected light, lower albedos, and so that cools the planet ever so slightly. And then ozone, depending on where it is in the atmosphere, can either cool or warm the atmosphere. But here you can see in gray, this is the impact of CO2 in our atmosphere on the amount of energy in the planet. And that's most definitely the major component in how much energy we're receiving. And this red line here is all of the human-caused factors, and that's just matching up very well with the observed amount of energy in our atmosphere right now. So it's a very good case that all the climate models are pointing to that human-caused impacts on climate are the majority of the reason why global warming is happening. But you may be saying, yeah, but what if the climate models are wrong? I don't know. They seem to be just tweaked to get whatever answer that you want. And this is just not true either. And the claims against it have been shown to be incredible. And so I think it's a good idea to kind of cover the basics of what a climate model is in order to talk about it more succinctly. So a climate model is a computer simulation of physical processes within a 3D grid on the Earth. And so the climate model will take a grid like this one, or usually even finer scale, and for every single one of these grid boxes, it will calculate the physical processes that we've talked about previously in this course. Things like latent heat flux, evaporation, all these different processes that are directly tied to physics and conservation of mass and energy. These are what's dictating these equations, and we can use very powerful computers to do these calculations for the millions of different grid cells in a climate model. And climate models have been incredibly accurate in the past. We've had climate models since the 1970s, and they've been incredibly good at predicting what our climate is today. This is the Broker climate model that came out in 1975, and it's plotted against are observed temperatures, yearly temperature averages in this colorful lines here. And it was pretty good even 45 years ago at predicting what our climate was. And since then, we've gotten steadily better at it. This is the 1981 Hansen model that predicted climate and was the model that led to the first congressional hearing about climate and James Hansen urging Congress to act if they don't want to end up with a completely different planet. They didn't end up acting significantly on climate change, but still climate models continued to get better and better. After that point, the IPCC was founded, and we had the first IPCC report that used climate models to forecast our climate. And you can see here that they're pretty good at predicting what we saw. And we've since had a new IPCC report every 5 years. And these black lines show that the predictions of our climate were in these stippled lines as their uncertainty. And every single time, the climate that we see falls within the uncertainty of the climate models. And as we go further and further towards 2007, and then 2013 with our fifth climate assessment, the model prediction was just right on the money. And you can see here, this is the synopsis of all the different differences between the observed climate and what the different climate models predicted. And in all of these different models, the rate of change of the warming of the planet was within 30% off, so not very significant. And current climate models are less than 10% off of observation, and so that's pretty accurate for being able to predict the future of our climate. Also, but it's important to realize that no model is going to be perfect. These are very complex systems. They're called chaotic, which means that small variations in initial conditions can cause large changes further on in prediction. And so generally, we need what's called an ensemble of models. Many different models that use slightly different but realistic parameters in order to predict climate. And the average of those models tends to be the most accurate of all of the models. So that's how we have more confidence in being able to predict our climate. All right, but you may have heard, yeah, there might be warming, but it's not having that big of an effect. The ice sheets aren't even melting. This is James Imhoff on the Senate floor, who's arguing that climate change doesn't exist because it's snowing outside. Not a very logical argument. But the ice sheets are significantly melting, and we'll talk about this more further on in the course. But you can see here, these are gravity measurements of Greenland. So when there's less ice, there's less gravity, and we can use satellites to record that gravity measurements. And what they show is that Greenland has been contributing a little less than a millimeter of sea level rise per year. Now, that might not seem like a lot, but that's 281 billion tons of ice being lost every year. And that number has only been increasing. The same has been true for Antarctica, where we see the rates of ice loss accelerating, especially in West Antarctica and the Amundsen Sea region in here, where we have over 1/3 of a millimeter per year. And so ice sheets are melting. There's no way of getting around that fact. And that melting has been related to climate change. We can also see here We don't have to only rely on gravity measurements. The same melt rates have been seen in altimetry measurements. So we use a LiDAR scanner in a satellite from space in order to determine the elevation of the ice. We see here that significant portions of Antarctica are losing elevation and therefore losing mass. And all that ice is going into the ocean. Yeah, but you may live on the coast and maybe you haven't seen that much change in sea level and you don't think it's that big of a deal. Well, let's listen to this guy's take on it.
Listen, my whole house got destroyed by Sandy, and I redid my whole house. People were like, "You're crazy, you should move." I said, "Absolutely not."
But you're standing in water right now. Maybe the people telling you to move were saying, at the very least, can you move up 5 inches to dry land?
Yeah, so a lot of times we don't realize the amount of sea level rise that's happening right under our noses. Literally. So sea level rise has been steadily rising at 3.3 millimeters per year. We can tell that both from tide gauge data in this blue line as well as in satellite data using that altimetry that I just talked about. And so sea level is rising and is expected to rise at an increased rate in the future. So sea level measurements match really well with modeled values. So these are the satellite measurements as well as the tide gauge measurements, and they match really well with the IPCC projections from the climate models. Sea level rise is a combination of two different processes. So not only do you have melting of the ice sheets and glaciers that are contributing to there being more water in the ocean and therefore the sea level rising, but also you have thermal expansion. So as the temperature of the Earth increases, the ocean absorbs a lot of that heat, and the hotter the ocean gets, the more it expands. And so those two processes are combining to cause the sea level to rise. And you can see that rise here. So sea level rise is not constant throughout the planet. And you can have different sea level rises depending on the different processes that are causing it to vary. New Jersey has some of the highest rates of sea level rise in the entire world. And one of the reasons is because of subsidence. So as you have groundwater pumping, the land actually deforms downward as you get that water is lost. And that's a significant issue, especially on the West Coast where you have a lot of overdraft occurring. Isostatic rebound. So whenever an ice sheet is lost and melts away, the resulting crust no longer has that weight on it, and so will rebound up, whereas the area around it will get deflected down. And that's what's happening in New Jersey, where you had the ice sheet from the last glacial maximum that's melted away, and now New Jersey is sinking because of that crustal deformation. Additionally, you can have ocean currents. So shifting of the Gulf Stream, for example, changes variability in sea level. You can see that here where the shifting of the position of the Gulf Stream causes variability in sea level. And then also gravity differences can cause variability in sea level. For example, all around Greenland, there's less ice there, and therefore there's less gravity pulling the ocean towards Greenland. And as a result, water is not as high there, and sea level is actually falling around the coast of Greenland because you have less gravity pulling that water towards Greenland, and it gets pushed into other regions. And so sea level rise is definitely happening. it's definitely important, and it's increasing its rate. And so it's something that we have to really watch out for. You can see here just how big of a problem it is. So these are the percent of the population that will be living in areas that will be completely underwater by the end of the century under a 2 degrees warming scenario. And in some countries, that's over 50%. 50% of the population that lives in areas that will be flooded. And in the United States, it's not all that much better. Between 10 and 25% of the population is expected to be in places that will regularly flood, even if we hold global warming to that 2 degrees Celsius limit that is the goal of the Paris Climate Agreement. So we expect to have significant amounts of people having to migrate to new areas and be dislocated because of climate change. Maybe you're thinking, yeah, but probably the economy is going to be fine. Climate change probably doesn't have that much of an effect on the economy. And unfortunately, that's not right either. So in the US alone, climate change, if not addressed, will cost $2 trillion per year. That's 10% of our GDP. And in other countries around the world, that's going to be significantly worse. Decreases in crop production and flooding and all these different impacts from climate change might decrease GDP as much as 50% in some countries. Importantly, too, the countries that will have the biggest decrease in GDP because of climate change are some of the countries that have contributed the least to climate carbon emissions. So there's a real environmental justice aspect of this, in which the countries that have been emitting the most, the United States, China, and these more northern countries, are going to be experiencing small changes. They're not small, it's $2 trillion, but relatively small impacts on their economy, despite the fact that they are the ones that are contributing most to climate change. And so that's a pretty awful situation to be in. So in the United States, the South is expected to experience the greatest economic impact from climate change. You can see here these are the economic impacts of different counties within the United States. And some areas of the United States are expected to have economic impacts all the way up to 27% of their total gross domestic product. And this is because a number of factors. Some of the main factors are decreased agricultural yields. We're not going to be able to grow as much in a much hotter climate. Mortality, when you have a lot of people dying of heat stroke and other related health issues, you have a big impact on your economy. Energy expenditure, if we're spending huge amounts of energy in order to have air conditioning, then that's a big economic draw. And then coastal impacts, when you have a lot of flooding, especially the South and the East Coast, are going to experience huge amounts of GDP loss just because of that flooding. And pretty much every single sector in our economy is likely to be affected by climate change. And by reducing our emissions, we likely save huge amounts of money. For example, if we follow an RCP 4.5 scenario, which is a scenario in which we are slowly but steadily decreasing our emissions, we'd be saving over $200 billion per year compared to a business as usual scenario. And so even just small reductions in our CO2 emissions can have big effects on the costs. And the cost to reduce our emissions are far, far less than the cost that they will have on our economy. And some of those major costs are cost to the labor pool. For example, farmers won't be able to have a job as readily as crops no longer become profitable to grow. You have extreme temperature mortality as people are dying of heat stroke. You have big economic impacts. All the way to air quality issues and impacts of flooding on roads. These are all impacts to our economy that will cost billions of dollars. And you can see here, these are all the different economic impacts for an RCP 8.5 business as usual scenario and an RCP 4.5 scenario. And sometimes, for example, in energy demand and supply, the air conditioning, for example, that I talked about, addressing climate change could save us over $5 billion per year in just that sector alone. So there's big impacts and big changes depending on which scenario that we follow. In New Jersey here, some of the biggest impacts are due to hurricanes. So hurricanes cause extensive wind damage and flood damage that you may have experienced yourself. And so already the amount of economic impacts and risk associated with these flooding and wind events are increasing, and that's going to have a big impact on our economy. You probably experienced during Sandy, there was a big impact on businesses after the damages that were caused due to that storm. Maybe you're saying, oh, this is not a good situation. We've really screwed the pooch on this. And so at least I still have my health. Well, not likely. Climate change has a big impact on health as well. You can see here all the different impacts that climate change can have on your health. The World Health Organization estimates that 250,000 deaths per year will occur between 2030 and 2050 due to climate change. And to put that into perspective, that far outpaces the number of the death rates for coronavirus. So climate change is a really significant cause of just mortality and death. And it's definitely something that is a moral issue that we should be avoiding. And the reason for all these deaths is because climate change has big impacts on air pollution, causing asthma. You have spread of infectious diseases and allergies. You have decreased water quality as you have more flooding into hazardous regions, more malnutrition as it's harder to grow crops, environmental degradation causing mental health impacts, and then, of course, heat-related deaths, the climate change actually killing people directly. So this is definitely something that's a serious issue. We can see here, zooming in on those infectious diseases, mosquito populations have been steadily gaining in the areas that they occupy due to climate change. And it's expected that mosquito populations carrying dangerous diseases will expand all the way up into Siberia and Canada in regions that they weren't present before. And that's a big cause of concern as you have more spread of these diseases such as malaria. On the right here, we see cases of Lyme disease. And because ticks can go into previously cooler climates, they're able to spread Lyme disease more easily now. And then here we also see dengue fever that's increasing its spread due to climate change. And all different diseases are expected to increase, let alone the fact that we might have novel diseases that are also spread more easily due to climate change. We can see here the impacts on asthma and allergies. Already, cases of asthma have been increasing. As you have more climate warming, you have more pollen outbreaks, and therefore more allergies. And this is another reason why people are suffering due to climate change. And so it's expected, you can see here, these are the additional deaths in thousands caused by changes in access to nutrition. And so around the world, it's going to be extremely more difficult to grow fruits and vegetables. And that lack of nutritional variety is expected to cause over 400,000 deaths around the world per year. And that's definitely not something to scoff about. Even in the United States, we're expected to have 40,000 deaths per year, additional deaths due to malnutrition that would be avoided if climate change was not happening. So there's a big impact on health. And then also mental health. You may have already experienced yourself that the idea of climate change causes a great amount of anxiety and depression and just makes you feel sad and incapable of change. And you're not alone in thinking that. Nearly half of Americans believe that climate change has already impacted their mental health. So this is a very serious concern, and especially in areas that have dislocations where people have lost their entire homes, in villages and towns due to climate change. These are only going to get worse, and the impacts on mental health are very significant. So you may be thinking, damn, this is really effed up. I just need a beer. Well, that's not necessarily going to be as easy under climate change as well. Beer prices are expected to significantly increase under more extreme climate scenarios. In some places, over 3 or 4 times more expensive for a single pint of beer. So your salvation might not be so easily obtainable. But there's still things that we can do about climate change. It's important to realize that climate change and acting on climate change is always better than not acting on climate change. And every action that we take to prevent climate change is an action to save lives. And the more that we act, the more harm we can prevent. So climate action is very important. And there's a couple different steps that you can take in order to try to reduce the impact of climate change. One of them being vote for candidates that support climate action, such as carbon taxes. Carbon taxes have been shown to significantly reduce a nation's emissions. You can see here that $50 per ton carbon tax can decrease the emissions of a country by nearly 30%. That's just one legislative act that significantly decreases emissions. And most of that money is going to a dividend to the society. So most lower income individuals don't even have an economic impact from this carbon tax. And you see there's several different countries that already have successful carbon taxes. Sweden, for example, having a $125 cost per ton of carbon, and they've significantly reduced their emissions. Additionally, it's important to support policies for increased funding for renewable energy. We're seeing the cost of wind and solar drastically decreasing, and the more it does so, the more economical it will be, and the more easily we can incorporate it into our economy. So making sure that we provide funding for that is very important, and we can call our legislators and make sure that they're supporting these policies. Additionally, talk to your friends and family about climate change. What's most important is that people know that you care about this issue. Go out and protest when you can, if it's safe for you to do so, and just make people know that this is a significant issue in your life. The more people care about this, the more likely that action is going to be occurring. And then you can reduce your personal carbon footprint. So there's a number of different ways that you can reduce your carbon footprint. These are the most impactful ones, such as having fewer children, driving less, and avoiding flying, whereas things like recycling and upgrading your light bulbs tend to have a fairly small impact on your carbon footprint. So knowing the things that are causing the biggest impact for you in terms of your carbon footprint is important. And then lastly, use your wallet as a weapon. Buy from companies that have addressed their emissions in their policies, and donate whenever possible to organizations that are helping fight climate change. And your fourth assignment will be talking about that more. And so hopefully you feel a little bit hopeful that we can do something about climate change. The time to act is now. The impacts of climate change are going to be incredibly substantial, and your voice in this fight is incredibly important. And so I'll leave you with this. This is a map showing the migration of different animals due to climate change to more northern regions. And I urge you to think about how you can reduce your own emissions and how you can help support policies that address climate change. All right, I'll see you guys next time, and thanks very much for watching. Bye.